Good morning, everybody. Welcome to the Paris Air Lab. Here is the Temple of Innovation for the future of air transport. And we are very accustomed to welcome high-profile professionals here, key decision makers who give us their view on the future of air transport and on the way decarbonization can be achieved in that industrial sector. But rarely have we been able to meet here on this stage, so many of them at the same moment. In a moment, in half an hour, we are very proud to have here the CTOs from the most important companies in the air transport domain. But first, we're going to have our first guest, our first keynote. And to introduce this person, I'm very glad to welcome on stage Hélène Ebner and Valérie Guénon.
Thank you so much. Good morning to the Paris Air Lab. It's a pleasure to be here. I've been here all week enjoying these exhibits and sending as many people as I can here because it's such an inspirational display of technologies related to decarbonization. Today, we have brought together the chief technology officers from several really key companies. We are collaborating across our industry, across OEMs and our engine partners. In order to make some change. We've got a lot of challenges to solve, whether it be around people and talent or climate change that really extend across the industry. How do we change slides? Slide change, please. Thank you. So one of the things we're going to talk about here, we're going to have a little bit of a tech talk, but just to help motivate it, I want to set the stage, and this is really relevant to all the displays in this room. We need to protect and grow the societal value that comes from our industry. Who traveled here by some sort of airplane? I see hands, exactly. Commercial aviation allows us to get together and provides an enormous amount of economic value. Over 87 million jobs, for example, $3.5 trillion of economic activity. And one of the imperatives we have today is really to reduce our climate impact. You can see here some strategies for doing that, and this actually aligns with the exhibits in the Air Lab. And one of the things that's really important about bringing the chief technology officers together is the role of innovation. So today we're going to hear about one key challenge related to reducing our impact to climate change. We're going to talk about some of the innovation that's required, some of the help needed we have working together with academia, and some of the important challenges that are going to be solved over the course of the coming decade in order to help grow our success in reducing impact to climate change. So innovation is key. We're going to have a tech talk, allow you all to ask a couple questions, and then bring on our chief technology officers to talk about science, technology, engineering, and math initiatives, and how we can grow some amazing career paths, hopefully for all of you in this room and many more people on the topic. And Valerie will help us set the stage.
Thank you. Hello, good morning, everyone. Helen, I was wondering, did you introduce yourself? Did you say you're from Boeing?
I forgot. Hi, everyone. I'm Ellen Ebner. I'm the Director for Sustainability and Future Mobility in Boeing Research and Technology Development.
Okay, great. So I'm Valérie Guénon. I work for the Safran Group as I take care of the products environment policies, and in particular for aircraft engines. Well, you can see this list of organizations, of companies. You can see Airbus, Boeing, Rolls-Royce, Pratt & Whitney, GE, Safran, Collins Aerospace, and Dassault Aviation. All these companies, we are customers, partners, competitors. We all work together to discuss some really subjects of common interest. And as Ellen explained, with this motivation, one of those subjects, which is the subject of today's keynote speech, is the climate impact of emissions that are not CO2. So, as you know, aircraft emit other emissions and they have other effects on the climate. So this is going to be the topic of the day. It's extremely important for us as industry because we need to understand what happens up there. We need to quantify it in order to be able to act on it. So it's really my pleasure today to introduce to you Nicolas Belloin. Nicolas has accepted to give this speech. Please, Nicolas. Nicolas is a climate scientist, specialist of the interactions between pollution particles and climate. He is professor of climate processes in the Department of Meteorology of the University of Reading in the UK. He is also chair of aviation and climate at Sorbonne University in Paris, where he leads the Climaviation research project on the climate impacts of aviation. He was a lead author of the Chapter 3, Human Influence on the Climate System, of the latest assessment report on the physical basis of climate change of the Intergovernmental Panel on Climate Change, IPCC, which in French is GIEC. Nicolas, the floor is yours.
Thank you very much, Hélène and Valérie, for the introduction, and good morning, everybody. So I lead a research project called Climaviation, which is funded by the French government and the European Union. And in this project, we study the non-CO2 impacts of aviation. And I want to tell you about those impacts, what they are, and why they are important. So before I talk about non-CO2, I need to talk about CO2, of course, and here the context is climate change. We know from the latest assessment report of the IPCC that we have a carbon budget, which is limited to stay under different levels of warming. And if we want to stay under 1.5 degrees of warming, we have about 400 gigatons CO2 left to get 2 out of 3 chance to make that warming level. And if we want to stay under 2 degrees, then the budget extends a bit to over 1,000 gigatons of CO2. And to give you the context, we emit about last year we emitted 37 gigatons of CO2 in the atmosphere, which means that we have about 10 years left in terms of budget. So that means that we don't have much time, and indeed the scenarios of the IPCC that remain under 2 degrees reach net zero carbon emissions between 2050 and 2080. So aviation in all this, aviation emitted just under 1 gigaton of CO2 in the atmosphere in 2018. That represented 2.5% of total CO2 emissions from human activities. And that means that about 2% of the increase in atmospheric CO2 in the atmosphere since pre-industrial times comes from aviation. What is a bit unique about aviation is that its CO2 emissions are growing. Before the COVID disruption, they increased by just under 25% over the 5-year period ending in 2018. So if growth continues at 5% per year over the next 15 years, it's already 20 gigatons of CO2 from aviation. So the industry is well aware of that, of course, and they are working on different levers to decarbonize aviation. So the first lever is to decrease fuel consumption by new aircraft, new engines and that are more efficient, and also make sure that the fleet is renewed so that those new aircraft and new engines are used. More efficient operation to make sure that the flights are as optimized as possible in terms of fuel consumption. And then there is a second lever, which is decarbonized energy. So switching away from fossil fuel, switching away from kerosene towards sustainable aviation fuels, so biofuels, electrofuels, even liquid hydrogen and electric aircraft. And here I show some example of future scenarios which have been put together by the International Civil Aviation Organization. As you see that depending on the level of ambition in the introduction of those new technologies, by 2050, there are different possibilities of emission reduction, although there will always remain some remaining emissions that will need to be offset. But, and that's the subject of the talk today, is not only about CO2. Aircraft emit many compounds into the atmosphere, and those are the typical emissions of a 1 hour flight. So there's CO2, of course, 8.5 tons of it emitted by that flight. But there's also water vapor, just over 3 tons emitted by the combustion of kerosene. And then there are a series of other gases, nitrogen oxide, sulfur dioxide, carbon monoxide, a few kilos of those. And finally, there are particles, solid and liquid particles, a few 100 grams, that are emitted, especially soot. And all of those things have a climate impact, and it's not because the mass emitted is small that the climate impact is small. So what are those climate impacts? Well, I think most of us know that CO2 exerts a greenhouse effect that warms the planet. But the other compounds also have their impacts. Water vapor and soot particle combine to form liquid droplets that then freeze into ice crystals. And that forms the contrails, the condensation trails that you see sometimes behind the aircraft or in the skies. There are a few today. And then those contrails are very cold, much colder than the surface, and some of them will spread and merge into large fields of ice clouds. And those ice clouds have their own greenhouse effect because they are much colder than the surface, and that warms the climate. But they will also reflect sunlight, which cools the climate. And we know that those two opposite effects partly compensate, but it is a warming that dominates, but we don't know its size. The soot particles also have an impact on clouds. They are transported by winds in the atmosphere. Aircraft emit particles very high in the atmosphere, so they stay there about 2 weeks. And during that time, they will modify the formation and evolution of clouds. And depending on the cloud you modify, you can have a warming or a cooling of the climate, and the total impact is still unknown. And then we have nitrogen oxides, which are produced by the high temperature in the aircraft engines. And those cause formation of ozone, which is a greenhouse gas and warms the climate, but later also cause a reduction in methane, which is also a greenhouse gas, so the reduction cools the climate. And here the net impact tends to oscillate between cooling and warming, depending on conditions. So as you can see, there are some things we know about non-CO2 impacts, but it's difficult to get the global impact. And the reason is that non-CO2 impacts depend strongly on the flight. So for CO2, if 2 flights emit the same amount of CO2 in the atmosphere, they have the same climate impact due to that CO2. It doesn't depend where those flights operate. But for non-CO2, especially for contrails, that is strongly dependent on the flight. Some flights will not form contrail at all. Others will form contrails that warm at different degrees. So here is an example. This is a satellite image that shows a contrail outbreak over central France. And you see that only a few flights contributed those contrails, and that's because they've flown into that region, which is identified in the weather forecast model, in a region which is cold and humid, where contrail formation is very likely. And then the climate impact will depend on the time of day, on the weather, and on the altitude of the flight. So it's a complex equation. So for that reason, the non-CO2 climate impacts are much more uncertain than the impacts of CO2. So they are measured in terms of relative forcing, which measures the perturbation to the Earth energy budget. So a positive relative forcing here in green, in red on the bar chart means a warming of the climate, and a negative forcing in blue on the bar chart means a cooling. The bar chart gives you the latest estimate of the relative forcing by aviation, with the non-CO2 and the CO2 impacts at the top, and then the overall impact at the bottom. So you see first that the leading cause of warming is the formation of contrails, with CO2 being second. And that means that looking at total aviation impact of aviation, about 2/3 of it might have been caused by non-CO2 impacts in 2018. But you also see the error bars, which are shown by those black lines, are very wide for non-CO2. And indeed, for contrails, the impact could be as small as half the CO2, which is already not negligible, but it could be as large as 3 times the CO2. And that's why there are research projects like Clean Aviation to try and reduce those uncertainties. So I started the talk talking about carbon budgets, and we can then ask, is it possible to introduce those non-CO2 impacts into the carbon budget? And this is where CO2 equivalence metrics come in. And it's not an easy thing to do because the CO2 and non-CO2 impacts of aviation operate on very different timescales. So non-CO2 impacts, especially contrails, tend to be fairly short-lived. Contrails last about 10 to 15 hours in the atmosphere, whereas CO2 is much longer-lived, with some molecules of CO2 staying in the atmosphere for hundreds of years. So there is not just one way to compare CO2 and non-CO2 impacts. It depends on what you are interested in. If you are interested in the energy gained by the system, in the relative forcing, or if you're interested in the temperature change, are you interested in short time scale, so 20 years, or are you more interested into a longer term, 100 years? So you see, for example, if you're interested in the energy gain over 20 years, then the non-CO2 impacts are quite a large addition to CO2 in terms of CO2 equivalence. But if you look at temperature change 100 years from now, then the non-CO2 impacts are essentially very small compared to CO2. So I started by saying that the aviation industry needs to decarbonize, needs to reduce its CO2 emissions, and they've got ideas to do that. But how will those ideas interact with non-CO2 impacts? Well, in terms of decreased fuel consumption, in terms of new engines, it's very difficult to build an engine that minimizes CO2 and non-CO2 emissions at the same time. For example, if you want to decrease NOx emissions, you want to operate at relatively low combustion temperatures, but that means that your engine is less efficient, and also you might emit more soot. So here, there's really a strong need for outstanding engineers to work on this compromise and try to create the engine of the future. Then there's more efficient operation to try to make sure that the flight uses as less fuel as possible. But it may be that for some flights, it will be interesting to reroute the flight, to change its trajectory so that to avoid the contrail forming regions. But of course, that might mean that we will start emitting more CO2. So here there is a trade-off that we need to solve. And for some contrails, the trade-off will be interesting in terms of climate benefits. But we will need to be able to predict which contrails to avoid, and where to fly and where not to fly, and to check whether the avoidance has worked. So here we need skills in terms of atmospheric physics, in terms of weather forecasting, in terms of climate science, in terms of measurements, but also in terms of policy, because there is this trade-off between CO2 and non-CO2 that needs to be solved. Finally, there is decarbonized energy, so moving to fuels that happen to emit less soot than kerosene, so low aromatic sustainable aviation fuel or hydrogen. But we already know that no soot doesn't mean no contrails. Those alternative fuels will form contrails, but those contrails will be different from the contrails formed by kerosene. So we don't really know what they will look like, what their climate impact will be. And here we need chemists, physicists to understand cloud formation, and people who know fuel chemistry and chemistry in the engines. So we need good people, and also we need to use them well. So there are ways to overcome all those challenges. We need to increase the number of research groups, because at the moment there are only few groups that work on the problem. And so we have only a few data points, which is difficult to build consensus and reduce uncertainties. We need to develop interdisciplinary collaboration, as I said, between engineering, physics, chemistry, meteorology, climatology. We need to increase the number and the quality of observations. Aircraft fly high in the atmosphere. We don't really know well what the distribution of water vapor is, for example, for contrail formation. We don't know well the properties of the particles many hours after emissions. And we just don't yet know what the emission of those new engines and new fuel will be, although there are already trials done by industry. And finally, aviation is not the only sector, of course, emitting things into the atmosphere, and all those things interact, which means that to minimize aviation, we also need to work with the other sectors. So that's it for me. Thank you very much for your attention. I wish you a good day.
Thank you, Nicolas, for that great talk. We have a few minutes, and so I think we can take a couple questions before we move on to our STEM panel with the CTOs. Does anybody have a question? I can bring you the mic if you have a question. Sure.
Thank you, Nicolas. Eric Dalbiez, Safran. You're calling for more collaboration on this scientific topic. Do you see already a community of scientists that are ready to jump in the subject, or is it a huge effort I would say, to have an inception of this kind of collaboration from a scientific standpoint?
There is definitely an increase in activity on the subject. The number of groups working actively increases, and that's true, for example, of clean aviation. We started 2 years ago, but we're still short compared to other climate problems, where you have tens of groups that works on the problem. At the moment, we are more into the high units. So yeah. So it started to change, and there's a lot of effort, there's a lot of investment from government and industry, but yeah, we need more.
Other questions?
Bruno Stoufflet, Dassault Aviation. Thank you for your talk, Nicolas. You presented a chart of David Lee,
yeah,
which is a reference considering the uncertainties we have on different components of the impact of aviation. I wanted to know if you see some recent publications, recent works, where we can have some hope that we will reduce the uncertainties we have on the non-CO2 effects.
For the moment, I don't think we are at the stage where we can reduce significantly the uncertainties. What we hope to do by the autumn is actually quantify some missing uncertainties, especially on the interaction between particles and clouds, which is kind of the elephant in the room in terms of uncertainty, because it's quite possible that will be a negative relative forcing. So that's we're hoping to have that in the autumn, but the uncertainty will be fairly large.
Next question. Any more?
And another one, is there a risk that the non-CO2 effects are so peculiar for aviation, because we are the sole to operate in high altitude, for instance, that this subject be some kind of a niche subject where you may have some problem also to create the case for many scientists to be interested in addressing this? Or do you see a potential for this non-CO2 effect to be addressed, serving a lot of other sectors? You had a mention at the end of your talk about this, but it's unclear to me whether the type of effects can be so peculiar to the usage of aviation that then it becomes a small subject instead of being broadly addressed.
Yes, that's a good question. So aviation is true is unique in many ways because it emits high in the atmosphere. So the compounds are in general longer lived than emissions at the surface. But aviation is not the only one to grapple with non-CO2 impacts and having to do trade-off between CO2 and non-CO2. The big sector that has to do that is agriculture, that needs to balance CO2 and methane emissions. And they have the same problem, for example, in terms of choosing the right CO2 equivalence matrix. And it's very debated. And there is a strong scientific community working on those subjects. And, you know, they could very well translate and work on the aviation in parallel.
Any others? Yes.
Yes, Arnaud from Visitez Super. So regarding decarbonization of energy, skills that are required, as you presented, are about atmospheric chemistry, physics, really scientist stuff. My question is, how struggling is it to work with engineering companies as Airbus or Boeing, for example? Because it's a bit different from the engineers that are part of this type of companies.
Well, that's probably a question for the CTOs that will follow me. I mean, in my experience, this kind of activities is developing in the companies. The sustainability departments are getting larger. I guess, Ellen, you can confirm. So I would think that there is a new strand of work in parallel to the more traditional engineering kind of careers.
Yes, absolutely. I think partnership is required. And I think actually, you know, our companies are working together with the CTO FORUM, which is what inspired us to look deeper at this topic because it's important to all of us. And it also inspired us to bring Nicolas in today and have this talk so that we could share with more people some of the good work that's ongoing, but also some of the challenges that I hope inspired you all as much as it inspired me, and hopefully will inspire some career paths and academic choices for you all here today. So I think with that, we're about out. So thank you so much, Nicolas. I really appreciate your time and your effort. All of us, thank you for joining us. On that note, now that we've all seen how these technical challenges are universal across our organizations, it brings to mind that there is a lot of potential for you all to contribute and for you all to have meaningful career paths. Addressing climate change is going to be a major challenge for decades for our industry. And so, you know, your futures can be made by working on this challenge with us. We're really excited about that. And with that, I will hand over to Cindy Walker, who's Boeing's Vice President for Engineering People Strategy, to introduce our Chief Technology Officers panel on science, technology, engineering, and maths initiatives. Thanks, Cindy.
Thank you. Yeah. Over here. Okay. Hello, everyone. Can you hear me? All right. I'd like to... Yeah.
Put the microphone right on your chin.
Okay. Whoa. Yes. Okay, that was really loud. Okay. All right. Okay, so I'd like to welcome each of our CTOs to the stage now. If you want to come on up. Yep. You can sit in any order. Yes.
Any order.
Yes. Hi, Bruno. Yeah, let's. So we have one who is on their way. Unfortunately, there was a flight delay this morning, which is kind of, since we're here talking about flight, it's kind of interesting. But he will be joining us in a moment. As Ellen mentioned, I'm Cindy Walker. I work for the Boeing Company. I have global engineering and people strategy. And I also have the opportunity to work with this group here, which is our chief technology officers for many of our large companies. We'll introduce all of them shortly. And also we have Dave Edwards here, who is from the Royal Aeronautical Society. So really looking forward to this panel discussion. Glad to be here. Part of my role with the CTOs is a forum that was established, a working group to talk about STEM, science, technology, engineering, and math, and how do we work together as companies to pursue a... okay, would you prefer me to use those? No, okay. To pursue together engaging more students into STEM and obviously very specifically into aerospace. So what we're going to do today is we're going to have each of our panelists answer a question that kind of gives you an introduction to them as well as an opportunity to hear about why they're passionate about aerospace. And then we will open up to the audience for questions, so you all have an opportunity to ask questions. And then following that, I'll just make a little bit more description about what we are doing as this consortium forum together, focused on STEM, to give you a little bit of insights on where we're going. So let me go ahead and get started here. And the first question is going to be for Sabine Kloek from Airbus. Okay. If you were a new graduate, would you choose a career in aerospace and why?
Thank you for the question. And yeah, maybe I start with how I felt as a young graduate. It's a bit of time ago now, but I had exactly that question. What shall I do? And it was one of the phases in my life which was maybe the most difficult, because I felt, wow, the whole world is on my shoulders and I have to choose now for my life. And only when I kind of got over that and said, okay, let's do the first step, next couple of years, and then I can still do so many things, then it got better. And so then if I think about today, I mean, we are in this exciting phase where everything is changing in aerospace. And how is it driven? We do have a real topic. The climate is changing, and we feel that every day. We could feel it even here around the last couple of days, and we have an urgency. So then you can always choose to be inside the problem to solve it, and this is what I really think is driving so many engineers around our companies. In our company, I mean, you see thousands of examples of how we tackle it, and I think this is really a chance for everybody today to be in it and to sort this question: how do we decarbonize aviation and actually prepare it for the next couple of decades? So you have the chance to be in that, and I think that's exactly where you should be today. Thank you.
Excellent. Thank you, Sabine. Let's go over to Bianca from General Electric Aerospace. What are some of the ways that we could be thinking bigger about inspiring the next generation, starting their education today?
So I think that we need to consider how we tell our stories. A lot of times the stories that are told about engineering, and particularly aerospace, are not good ones. And there's a lot of wonderful stories to be telling about how we improve the world, how we impact people's lives every day as engineers and scientists. And I think that we need to reach out and figure out how to convey that message in the public realm, not just to those who are already excited and interested in aerospace, but to those who never thought about it, to children in primary school, to parents who never completed their education. Think about how does it become more visible in stories, games, apps, movies and TV series, things that people really connect to on a basic level and then become excited and interested and want to be part of our team that is really impacting the world. And I think that there are lots of opportunities to do that if we focus on it, if we collaborate and come up with what are the great stories that we have to tell.
Wonderful. Thank you. Thank you, Bianca. Okay, over to Michael Winters from Pratt & Whitney. Here's your question. How do you view the progress of technology in the aerospace industry, and how will that change how Pratt & Whitney hires and prepares itself for the future?
So today at Pratt & Whitney, we design, develop, manufacture, and support propulsion systems. And the technologies are changing in very vast ways. And when you look at the challenges of tomorrow, what are they? It's powering freedom and sustainable aviation. And in order to rise to those challenges, there are new technologies come into play. For the F-35, powered by the F-135 engine, for example, to be able to fly faster than 1.5 times the speed of sound and then stop and land vertically took inventing whole new classes of applied mathematics, faster computers, and new algorithms that allowed the airplane to be able to function that way and the propulsion system to deliver that performance. And so when you think about the propulsion systems of the future, they become cyber-physical entities. And then we look at sustainable aviation, and we look at the changes, the shifts in technology. And it's not just about combustion and aerodynamics. We're bringing in hybrid electrification of flight. We're bringing in new types of fuels like sustainable aviation fuels and the associated chemistries. We're bringing in hydrogen and handling of cryogenics, new thermodynamic cycles, and understanding the vast impacts that we just heard about, for example, in terms of contrails. All those involve totally new types of skill sets than we've been hiring up until now. Electrical engineers, coding, new mathematics, all kinds of new skill sets. And it really doesn't matter as students which of those you choose. The key is to be passionate about it, to embrace it, and not just stand tall in learning your field, but learning how to think about technology, because the technologies will shift during your lifetimes and your careers, and you will need to be able to understand how to think about those technologies and rise to that challenge.
Thank you, Michael. That was awesome. Appreciate it. Okay. Let's go to Rolls-Royce now with Gracia Vidadini. Gracia, what can be done to improve diversity in STEM?
Thank you, Cindy. That's a great question, and it's a topic very close to not only my heart, Eric, it's our heart. We sit here, you know, we know each other. We discuss a lot about topics, but, you know, we represent companies which are fierce competitors, right? But when it comes to important things like diversity, like STEM, we speak with one voice. And of course, we've been discussing a lot about what can we do to improve diversity, to encourage young people to come and join this amazing industry we're a part of. And, you know, just let me share an observation with you. Have a look. How many young people are environmental activists today, especially young women? There's many, many young people going at great lengths to really speak, have their voice heard, in order to raise awareness on the situation when it comes to sustainability risks we are facing. And our planet is not in a good shape, right? And there's no planet B. Well, this is great. We need activism. We need activism to speak to our collective conscience, also to fact check what we industries are doing on the subject. But, you know, if you want to solve things, speaking is not enough. You have to do things. And being an engineer is the best possible route you can take to solve problems, right? So great speaking, raising knowledge, raising awareness, but do consider taking that path, the engineering path, and join us into really finding a fix collectively, speaking one voice when it comes to topics that really matter, and find a solution to the most burning challenges our industry faces. Thank you.
That was great. You're already getting claps. Yes, go ahead. Clap for... Thank you, Grazia. Okay, now, unfortunately, Eric, you've got to follow that one. For Safran, Eric Dalbiz.
Yeah.
So your question is, why do you care so much about STEM and aerospace, and why is it so important to you?
Yeah. So I hope I will also raise some points that can be shared and voiced by each and any of my colleagues around me, speaking one voice. STEM for me, related to aerospace, something very simple you can perfectly understand. We're all working in an industry where we want to optimize, we want to do a lot of things, but there is something we will never compromise: flight safety. Flight safety, this means that we have to understand what happens, and after that we have to demonstrate to third parties, authorities, that they can rely on our analysis to say our systems are safe, are airworthy, and you, as a traveler, you can take the plane without a concern of it. And demonstrating flight safety is about making analysis. And that's here where science, technology, engineering, math are the basement of the disciplines we have to master, because we are not just trusted because we are reasonable people or responsible people. We are trusted because we go into the demonstration of what we are saying. And STEM is really necessary for this. It's all about, it's a school of rigor. And rigor is mandatory in our sector, not just in our sector, but especially in our sector, because flight safety is the first challenge we will never compromise. We have to optimize the rest and so on. And my second remark also is about one of the revolutions we are currently experiencing in our sector. Okay, we are tackling the climate change and so on, but we have also to address what's happening with the data science revolution and the digitalization. And data science and digitalization, it's all about facts and figures and so on. And this requires the scientific approach on it. Otherwise, you're just describing something you tend to have understood, but there is no solid foundation behind this. So for these two reasons, just on top of what has been said, these STEM disciplines are core and key for us. That's really something that is driving the mindset of all our industry, wherever you are in the value chain of this industry. So that's really critical.
Fantastic. Thank you, Eric. Okay, let's move over to Bruno Stoufflet. We're just going to ask you a simple one. What really inspired you to go into the aerospace field?
Good. I will talk about my experience. I started in the 80s. Maybe I'm the oldest here. Certainly. In aerospace industry, you meet two kinds of people. People who knew very young in their childhood that they would work in aerospace, mostly like as pilot and then as engineers. People even when they were very young. And you have a second kind of people who are very fond of science, in different fields, and who join aerospace industry. That was my case. I started in applied mathematics. I was very fond of applied mathematics, developing simulations, and I met some people from Dassault Aviation when the aimez shuttle started, the European shuttle project, and I enjoyed very much to join this company, and I think it's the same in other companies, because when you are a scientist, you have the possibility to interact with other scientists from different fields, because to develop an aircraft, you need the combination of several expertise, not only mathematicians, but people who understand physical models, people we can compute on high performance computing facilities, and so it's what it was very much enjoyable in this work is really to have the capacity to interact between different expertises. And I think you are at a moment, and I will complement what Eric says, where you have challenges which will completely change the aeronautics of the future. The first one is the capacity to analyze data, and then this data analytics will impact all the engineering teams in the different fields, because we will not only rely on physical simulation, but we will have to enrich them with data coming from operational activities. And the second one is the challenge of climate, where we need new expertise, not only in-house, but also working with academia. That was mentioned by Nicolas Belloin just before.
Excellent. Thank you, Bruno. And the last of the CTOs before we get to Dave, Todd from the Boeing Company. If you were to go back and give advice to your primary school, what advice would you give to yourself about STEM?
Sounds like an exciting question to invent. But let me start out with why I and we are all so passionate about this subject. And just a short story. I was in Germany yesterday. Okay. So we need to eat the microphone. I was in Germany yesterday, flying on a flight back to Paris last night, and my flight got canceled, and there were no flights to Paris. It would have been really easy at that point to say, that's it, have somebody else come up on stage and we can move on. But I didn't do that. So I actually had quite the adventure, but got on a train to go to a different city that had a flight that could get to Paris theoretically on time. Pretty close, 5 minutes, not bad. But why am I so passionate about this subject, about talking to all of you? And it's really because of what aerospace does for the world. Aerospace has changed the history of the world. And what COVID, I think, has taught us, among various things, is there's a very innate human need to connect, to be with others physically, to see each other. It's just not the same. The best technology clearly has not replaced it, because you can see in the resurgence of air travel how important it is to the world to connect. And we can do that in a sustainable way. But it requires talent, it requires innovation, it requires passion and perseverance to make it happen. And so to your question, Cindy, about what would I tell my younger self, I think engineers are naturally curious about how things work. So I would say, take the opportunity to learn how things work. Take things apart. You have to talk to your parents about that, but take things apart. Build things, whether it's a rocket or even an airplane, a model airplane, a paper airplane. If you think about the Wright brothers, they'd have invented a wind tunnel in their house. All this is possible. It is possible to invent the future right there and go on and get the formal education in school. And so to all the parents and educators and students in the audience, I just encourage you to join us in continuing the amazing history of aerospace, and really at its core, enabling humans to connect to make the world a better place. So look forward to more discussion.
Great, thank you, Todd. So now you've had an opportunity to hear from each of our leaders here, from a business and industry perspective. And now I'd just like to ask Dave Edwards, who is the Chief Officer for the Royal Aeronautical Society. What do you see as you work with different companies and lots of different organizations that you come to interface with, universities, et cetera? What do you see as something that all of these CTOs and their representatives could do individually to help with STEM? How can they encourage?
I think I'll start off by saying I'm the non-engineer on the panel, so don't boo me, okay? This collaboration is the key to all of this. It's aviation, aerospace, space, it is a competitive landscape, but for this part of it, you see all the CTOs coming together to talk about how we can make sure that that next generation follows them. I will give you a hint. When they left college, university, none of them thought they will be sat here as CTOs. I guarantee it. But amongst all of you down here, you can be here. There's nothing stopping you from being up here. I'm also going to guess that the younger people in the audience are probably STEM-y kind of people. You're probably fairly engaged to come and listen to a STEM panel. So I want to make sure that the kids who you grew up with also get the same message. And that really is what this is about. It's about how do we make sure that the educators that Todd mentioned, how do we make sure that parents understand the opportunities that are available to us all? Because none of us look back on our careers and think, oh, I hated it. I hated getting up in the morning. I've worked in something I love since I was 14. I joke quite often, I have 0 transferable skills to leave it, but I just love what I do. And that's what this is all about. It's finding those opportunities to make sure that governments, regulators, industry, parents, teachers, you to your friends, just inspire the next generation to come with us. And I would say that if you are already here and you're in the industry, go out and talk about it. Go to schools. I went to talk to a primary school, and I was told I was going to talk to a group of 11-year-olds, and I thought, great, lovely presentation, it's going to have pictures of planes in it. And I walked in, and it was a school of 5-year-olds. I'm like, whoa, okay. And I just said, okay, so what do you want to be? And the hands all go up. I realize I'm hogging this story here, but the hands go up, and I want to be a professional horse racer. Okay. I want to be a professional footballer. Okay. I want to be a professional boxer. And to be honest, that 5-year-old could have punched me, I'm quite sure. But this little kid just wants to be, and I was thinking they all want to be professional some things. And yet this is the best profession you could get into. You can fix things, you can solve problems. But without that next generation coming to support all of these people when they shuffle off with me to the retirement home, you know, that's the problem that we've got to fix now. So there you go.
Thank you, David. Okay, so now we would like to have the opportunity for you all to ask questions. That's really, you know, give you an idea of what their passions are, and you can hear it in their voices and in their stories. But what kinds of questions would you like to ask? So we're going to have a mic runner right here. Okay, you're going to steal mine. Oh, you want to steal? Okay, all right. So you can stand just for a moment, Caitlin. This is the mic runner. She is my daughter. And a recent graduate with a master's in electrical engineering and is a Boeing engineer as of January this year. So any of you who are interested, she's also be around to talk, but she's my official mic runner. So that's my responsibility to further this, you know, STEM, advanced STEM. There's my example. So as like Dave was talking about. So, all right. Question. Yep, right here.
So hello, I am engineering student in Aix-La Rochelle, so in France, and I'm more specialized in digital transformation, which is very interesting, data. And I have a question, because we know nowadays that climate change is probably the biggest challenge that we are facing, and we know that it is important that the aviation field has to develop in this way. So I have a question to ask if you collaborate, and how do you collaborate to accelerate the development of new technologies and also new aircrafts that are that have less emissions, and also how do you manage the industrialization of these new aircrafts? Thank you.
Excellent question. Who would like to start?
Shall I start, and then I try to keep it short? But you're exactly right. I mean, we call it the fourth revolution in aerospace now. Yeah? The first one was to fly at all. The second one was on safety, and we've heard about it. And then it was about democratization, opening up. Now it is about getting decarbonized, getting sustainable. And we really see it as the license to operate, because if we are not taking that in hand and changing, we might be out. And despite the fact that we all need mobility, we all need to connect, and we think it will stay at the heart. So your question was, and I think this is really the core point, we want to have impact as youngsters. So, and this is exactly where we are. We are in this revolution, and we are in the pioneering phase again. If you haven't been there for the last couple of days, we are now directly back into it. And we exactly need this link of kind of the experienced aerospace people together and mixing that with digitalization experts, with experts that are really passionate by AI, by the new technologies. And this together will make the difference. And if you ask us how we collaborate, then it's really on the things where we can collaborate without any fear. So, of course, the SAFs are one, sustainable aviation fuels. We all are very much together in this to fight for getting more, because here it's not about technology anymore, it's about an industrial uptake. We also learn together on climate impact, climate models, NOx, what is there else than CO2 and how exactly does it work. And this is really the strength of this community, because we're all technical people. We are not so much political. And so we have to look for the things where we can well work together without competition. But it's exactly in understanding the impact and bringing that forward that we're going forward. So STEM is one thing. We have a kind of a climate understanding working group, the NOx understanding working group. We're comparing our models and working with the science, and then taking it forward this way.
Thank you, Sabine. Your question was also, well, the link with collaboration and also industrialization. The first way I think we have to collaborate is to be aligned on the same schedule. That's the first way we do it. And there is a climate urgency. So that's really quite remarkable in our industry to be in a position to have exactly the same schedule, because we had to meet the climate change urgency. It's not so obvious, you know, if you compare with other industrial domains, to have the same approach. Sabine, Todd, Bruno, Grazia could have exactly the same speech as I'm giving to you if we have to say, oh, do we have an agenda? When do we have to be at the rendezvous? And what are the levers inside? We share the same trajectory. That's the level of the collaboration. And the second aspect that is critical for us is that we do not have time, because there is an urgency. So, to make it simple, here you have the engineers for the engine part of the table. Here you have the aircraft makers. Who will make the decision? Who will create the case for the new aviation? Obviously, the aircraft makers. We are not flying engines. We are flying with aircraft. What do they need, these guys and the women here? They need no later than mid-next decade, 2035, let's say, to enter into service their next generation of aircraft that will make it possible to tackle the climate challenge. When do they want to take the decision that they enter into the development phase of it? A few years before. Let's say end of this decade, to make it simple, in a nutshell. So this means that we have in front of us just 4 to 5 years, no more, to make it possible for this person to take the decision to pick up the best technologies to make their aircraft program a success for sure, de-risking their program. And now I refer to your question about industrialization. As you understand, we are now not in the position to start this aircraft program. We are all together preparing the technology so that in 4 or 5 years down the road, they can start the development. What do they need? They need to enter this phase with a good confidence that if they pick and choose each and any of the technologies that are made available at that time, this will be a low-risk program for them. This means that what do we need to prepare? The maturity of the technology, for sure. It must work. But we must also have prepared at the same time the industrialization of this technology. So it's not just a question of maturity on a technology readiness level scale, it's also on the manufacturability and even the maintenance readiness level. So that's fair. I wouldn't say it's completely new. It's true that in the past, we were very much focused on technology readiness, and maybe we did not pay so much attention to the fact that at the same time, it must be ready to embark from a manufacturability standpoint, industrialization standpoint, and so on. So due to also this urgency, it's been necessary for us to synchronize both because the time is short for us.
So Eric, we actually do like engine manufacturers. So, I mean, we have to do this as a community. And you started your question with digital and digital transformation. And I think inherent in that technology is also sustainability, because the ability to build things in the virtual world means we're wasting a lot less material iterating on designs and iterating in the build. So that's really important. Another aspect of digital transformation is additive manufacturing or 3D printing. If you compare adding material to build something versus subtracting, milling material, there's a huge difference in the sustainability. Much less energy, much less material with those technologies. But we have to bring it all together, and that goes to your question of collaboration. And collaboration is inherent. It takes the community to build the next airplane. And so we collaborate in various ways. One is in standards, so that the standards for the digital interface of data or standards for sustainable aviation fuel, there's just a large number of standards where we all participate together to set those standards in a way that benefits all of us and achieves that more sustainable future. So I think that collaboration is very important.
So there are a number of ways where we can collaborate in a pre-competitive way. A great example, an exhibit of that, is last Thursday on the 15th, the CTOs all signed a common joint statement for policy to advance the adoption of sustainable aviation fuels on a global scale, to embrace it, to give common standards, to give common metrics, and to define a constant demand signal so that the manufacturers will produce and capitalize to produce the sustainable aviation fuels. The next area where we can come together, and we do, as Todd was just saying, is in certification standards as well. As we think about these new technologies, there's going to be a lot to learn, and some of these, for example, as you start to bring in higher voltages to make some of the propulsion system electric, you start to cross over the different certification chapters that are required. And so there's going to be embracing the new policies that get us there, because as we've all committed, whatever new technology we bring to the market will be as safe or safer than what is flying today. Okay, and then the third area is working with the universities. We all, every one of us, collaborates with professors, and we embrace the students, and we help define the public-private partnerships that fund the research that's fueling the next wave of technology.
Yes, I want to complement saying that what is remarkable is that even if the agenda, the agenda towards decarbonization is driven by Airbus, by Boeing, it embarks all the sectors of aviation. And an airframer as Dassault Aviation, which manufacture business aircraft, has the same agenda and the same target in 2050 of decarbonization. And it's why we can collaborate together. And in some fields, we will be pioneer, in others, we will be behind, but we have the same agenda. And I think we have to really underline this.
Bianca and I would like to wish you a great International Women in Engineering Day. So just go on with your studies, finish your university, and come and join us on stage.
Thank you for sharing. You talked a lot about collaboration. Does it go beyond until pattern sharing or this kind of things? Are companies ready to work that hard together? Is there a world where we are going to see an Airbus employee going to work in Boeing facility or use an exchange about stuff and maybe industrial means and technologies?
It's a great question, and actually there are activities where Airbus and Boeing are collaborating together on joint teams, not just what you see here, but there's also some emerging standards relative to communications with aircrafts, for example, and how to provide more information back and forth to the airplane, and part of that improves sustainability as well and reliability of the product. So there are places. It's certainly, we're great competitors, but we also have places that we work together.
Yes, and then, of course, research projects, most of them are really collaborations between many companies and universities and scientific institutions. So this is where we are really sharing the path forward. And I mean, I'm talking here for maybe the European environment a bit more, but then all of them are basically, we're joining each other, not always all together, but it's always about corporations, because not one alone can do that path. That's impossible. We really need to build together. And that's going in the industry, of course, sometimes even beyond, and especially if we are looking to the new technologies now.
We have a really strong history of partnering on products. In particular, our CFM partnership is one of the oldest between GE and Safran. So we see generations of engines that are joint created, invented, and supported throughout their life cycle. And we also partner with Pratt and Rolls in order to develop in certain areas where it's beneficial to us. So that's something that if you see it as a opportunity where there's a need for the two companies' expertise to come together, that's often when you find those partnerships.
There is one fundamental truth, and that is that the laws of physics and chemistry don't change when you go from one side of the Atlantic to the other. And so as one company learns something, we all learn from each other. We watch each other. And in some cases, it's through collaboration. In some cases, it's through study and learning and understanding. And it's great. We see the whole industry moving forward. And this is a really, really exciting time. You know, over the last decade and a half, we've seen a migration out of the aerospace from a lot of the recent graduates of engineering to tech, to high tech, to digital. And especially to the kids out there, the world's changing so fast. Our world in propulsion and in airframes is changing so fast that we're embracing all those new technologies. As Todd said, digital is now about everything we do. We use machine learning to synthesize how the engines and how the airplanes play together and work together to optimize the system. This is a really exciting time, and there's so much that all of you can contribute to our industry with the chemistry and the physics, as well as all the digital sciences that come to bear as we look to the future.
Just as from a social science point of view, if you get to a child 7 times with the same message, it's more likely to stick. If each of us individually go and say, you know, Boeing says this is the way to engage with kids, Airbus say this is the way to engage with kids, I say this is the way to engage with kids, it's 7 wasted opportunities. If we collaborate on this particular part and say the same message with a different brand, so we can all get their moments in the sun, but ultimately we all say the same thing, we're more likely to hook those kids into that message. So companies can collaborate in areas, obviously they're all trying to compete with each other, but on this one, if we don't have the next generation of STEM coming into our industries, that will be a bigger challenge than climate change has ever been to our sector, because we won't have the people to fix the problem.
A word maybe about collaboration versus competition. In our industry, as Bianca, you said, for GE and Safran, we are able to work hand in hand for the CFM venture and journey, serving our customers, and at the same time, we are head-to-head on other business sectors, and this is not a problem. What is a cooperation? A cooperation is the result of an alignment of different interests. These interests may be different between you and us, but on a given topic, with a given object, it ticks the box of Safran on the one hand side, it ticks the box of GE. So let's do it together and in a very efficient manner. On other aspects, it doesn't tick the box for eternity, and we will compete. And competition has a virtue as well. Competition is creating optionality for the customers. And it's also a way to accelerate the pace of innovation. When you compete, you want to be the first entrant on the market. So you accelerate your own path for innovation because you want to have this premium. So on some topics, you have to elect whether it's better to compete or to collaborate. It's not contradictory. And for pre-competitive aspects, for sure, very often we contemplate the pre-competitive topics more as an option to collaborate by principle rather than to compete. And that's the way we operate in the aerospace. Sometimes it's odd when you discuss with other industrial sectors, they say, how can you be so close on this topic and in fierce competition on another one between both corporates? That's the possibility. That's the reason why we do it that way.
Thank you. 2 excellent questions. How about a third?
So, hello, I'm Felicity from Isary Superior in Toulouse in France. And my question is more about us and is how do your companies engage with engineering school to promote the education of future engineers like us in the field of decarbonization, and what opportunities do you offer to us in research development field, in this field, for example?
So I'll start. So we have a program at GE called GE Next Engineers, and we really start fundamentally with what are the engineering principles, but we build it around sustainability needs of the world, essentially, in order to really broaden the mind of students who maybe wouldn't have been exposed to engineering, and give them an opportunity to have a curriculum in high school, in their secondary school, to understand what is the design process, how they can work with teams in order to solve problems. And I think that it's really fundamentally important that we start to grow these initiatives. And that's one of the things that we've been talking about with the STEM advocacy, is how we can build upon that and not have it be just a few hundred students. I think we have 800 students in our program right now. I know Boeing has similar kinds of initiatives that they work on, but how can it be accessible broadly?
At Rolls-Royce, we rely a lot of internships. And just 3 days ago, I was on this very stage giving an award to Amelia Gilchrist, one of our Rolls-Royce interns, who turned out being one of the top 5 clean aviation environmental ambassadors, chosen among hundreds, because of a very specific program she's led on indexing the sustainability of our manufacturing processes. So environmental sustainability is at the top of Rolls-Royce priorities, and we rely a lot on our interns to give us new ideas and come up with new processes to really help us fulfill our ambitions in this sense.
I think one of the things that I think we've all learned is we have to start young. So we really have to start in grade schools and then high schools and universities. And again, I think each of us have programs like this. For Boeing, we have something called the Newton Rooms, where we equip a trailer with a number of different lesson plans that teachers can use with both physical artifacts, that they can manipulate models and things of that type, as well as things that they can do in the virtual world, and all part of sparking that interest and seeing what would it be like to be in aerospace. And we do that grade school, high school, and with the universities, specifically relative to sustainability, there's a number of programs in different universities around the world that we sponsor students and research to develop more bandwidth, more talent in that field. And within the company, we have organizations specifically dedicated to sustainability. But what's probably most important is sustainability's got to be central to how we do engineering all across the board. It can't be that there's this team over here that does sustainability. It has to change the way we all do things, and thinking about what kind of waste would be generated in the design that we have, et cetera. So it's really important to have that holistic approach.
So we do a number of things as well. We have embraced an engineering ambassadors program. We actually identify engineers that we send out to the universities, and they go there to mentor and develop students and excite them to come into our industry. We have an eSTEM scholarship program that we've been deploying, which is about a $25,000 scholarship. And we also, reaching to the younger, to the high schools, we sponsor a number of design challenges, the Real World Design Challenge to design aircraft and propulsion systems, the Rocketry Challenge, where the international competition was held right here this morning. We proudly sponsor that as well. So to inspire the students, the next generation, starting in the high schools, to get excited about aerospace and then follow that through as they traverse their journey through the university and into the industry.
In addition to what has been said, for instance, other groups, Safran, we're doing that, but others do. We organize also innovation contests specifically dedicated to schools and university, like hackathons and things like this. I don't know if you were in, but this afternoon we're here at Le Bourget Air Show. Safran will have the award ceremony for the winning team of a recently launched innovation contest as well. So there are many ways to engage, as you say, and that's the beauty of it, because there is no silver bullet to do it. We have a variety of ways and means to address it, and this must be in the right context. Sometimes it must depend also on the cultural context of the population we have to address. Yeah, see. So it's all about this.
And as we are talking with one voice, we're doing all of that, of course, as well. I think there was another question just behind you.
Hi, Charles Janiak, Boeing Research and Technology. So this is more of a comment than a question, but you can comment on it. I find that when I tell people I work at a tech company and they say, which one? Which one? Tell me all about it. I say Boeing, and they are disappointed. And that, my point is that there is a misconception or a changes of attitude toward aerospace where people do not consider it as the leading edge, as the tech company, which is all digital, which is a problem for our digital transformation. And my question is, what are you doing to change that perception?
I have to react spontaneously here. This is exactly the reason why we are all sitting here together. And not only sitting, that's as well part of, the purpose of our group. We are exactly at the heart of it. And we have to go out and talk about it. And I think Paris Air Lab is also really a great example of showing all what is in. It's just awesome.
I think building on Sabine's point, it's really, I think, doing more to make to grow the awareness of the innovation that's taking place in aerospace. I mean, many examples. We just launched the world's largest rocket recently. Last year, the world's first autonomous aerial refueling system, and there's many others across the companies. But probably what we could do better at is making the larger population aware of that innovation.
And this is also the beauty of living in a democratic system, right? That there's people with different opinions, and this triggers a dialogue like the one we're having here. So we welcome the debate.
Yes, to complement, we have specific difficulties with digital skills. People who have these digital skills, because they say in startups, I will have very short cycles in development. I will be in my in the context where I have experts around me in digital technologies, and so we have first to shorten our cycles by doing new types of products, services, and to show that we also have short cycles in developing new functions for our aircraft, for our customers, for our pilots, first. And second is to show that they will benefit in our industry of what I said in my first intervention, is that you will interact with people who have different skills, different expertise, and it will enrich your work and your experience.
There's certainly a generational thing. I think we have to accept that, you know, we can't fix immediately the problem today. But yesterday en route here, I went to the Big Bang Fair in the UK. It's 20,000 kids from high schools, and they get immersed in a room, well, the NEC, so a huge exhibition hall. And if you go into that, all of these organizations are represented there. And so aerospace is very much punching back at exactly that. You know, you're there with all of the other tech companies, but you see kids folding paper aeroplanes and think it's as simple as that. The first day is just as simple as getting them to fold a paper aeroplane. But then just the journey that they were going on yesterday in my short visit, just immense. So yeah, it's, you know, I think we've learned the lessons. I think we're doing stuff already at primary school. But, you know, we can't always create a revolution that quickly, unfortunately.
And just, not a joke, tonight after the show, you will leave the Paris Air Show. Maybe you have a car or you will take a taxi. So you will turn on your car. You will probably light on your GPS in the car. This is inherited from the aerospace industry. You will probably, if you have a modern car, you will have a head-up display to help you have your speed and so on just in front of your eyes. This is inherited from the aerospace industry decades ago. Your car has probably an anti-lock braking system for the safety issues. This is inherited from technologies that were implemented first on aircraft. So the link, you know, I think hopefully you have understood that what we are tackling now is something that is core and key for the societal challenges of our world. We are not working on something aside what matters. And on top of that, I wanted just to illustrate the bridges that do exist, especially in the field of technology, between, and both sides actually, between the aerospace and other industries. So it deserves attention, I think.
So I want to build on what was just said. I want everybody to think about what is the legacy you're going to leave, right? Do you want to say, I developed an app? Or do you want to say, the world in 2019, commercial aviation burned 100 billion gallons of fuel, and I introduced new technologies that reduce that number to keep people flying, the improvements in quality of life that we heard about from Todd, and be able to sustain that, and at the same time, do that in an environmentally sound and conscious way. What legacy do each of you want to leave?
Well said.
Just really quickly, I feel like to that point, the fact that when we work on technology in aerospace, that technology stays out there for 20, 30, 40 years still being used. It's not superseded that quickly because it is so challenging. I think that's something that points to how proud we should be of our industry.
Thank you. Sabine, did you want to say add?
Yeah, I mean, Bruno said it so well. He is an advanced metaphysicist, right? So we are actually, by bringing the things together and the different technologies, so now the digital technologies and the advanced software technologies, showing how the application cases and building the bridges here into the application, this is so powerful. And I've seen people emerging there. It's just wonderful. And that's what we need to create. And then we have to talk about it so that it's more visible and as well more conscious in our minds.
Thank you. One last question before we do a wrap up. And you've been patiently waiting. Thank you.
Thank you. I have a question about technology. I study...
Closer.
Okay, thank you. I'm Thibaut Chaler. I study at ISAE Supmeca in Paris. I have a question about technologies. And in your opinion, what is the area of innovation that has the most potential to reduce climate change? For example, innovation in materials or innovation in energy. And what do you think about the better type of innovation?
So it's a great question. And the answer is probably all of them.
I think we're done.
Right? We are all working on a number of technologies across the industry, new airframe concepts, new propulsion technologies. And we're going to learn it's not going to necessarily be one size fits all. But there are some really good things that we could take away on the path towards our net zero by 2050 that our industry has committed to. No, to go electric, batteries are really heavy. But today, if you introduce batteries and just go mild hybrid electric, you introduce new efficiencies in today's propulsion systems that can be embraced. And we're all working on that across the industry. And we're learning about that and bringing it forward. Alternative fuels, sustainable aviation fuel and hydrogen. We're learning how to bring them to market. And we're finding that even some of the technologies that become enabling for hydrogen bring value at an earlier time, even right now, in terms of demonstrations we're doing here in Europe, collaboratively under the Clean Aviation Program, that will bring and enhance dramatically the efficiency of engines today. And so we're really excited. There isn't going to be one size fits all, but it is going to be a systems engineering problem, and we're going to find the right solutions that fit each of the respective markets.
Yeah. I think, agree, it's all of that. And if we think about the focus on sustainability, on the one hand, as industry, we've improved the efficiency, the fuel efficiency, which reduces emissions, by over 80% since the dawn of the jet age. And that trend continues, but there's a lot of ways we can accelerate that with improvements in the design of the aircraft as well as the engine system. And I think the digital revolution, the digital engineering, is allowing us not only to make the design more efficient, more sustainable, but the design process becomes more efficient and sustainable. And lastly, with the recent advances in computing power that have enabled the AI revolution that's taking place, that ability to optimize at a much larger scale, I think, is unlocking even additional opportunities to make things more sustainable.
Michael used a key word, which was systems. It's a systems problem. All of these pieces integrate together and impact each other. So any one change that you make is going to affect that whole system, and you have to optimize it as a whole, not individually in any one area.
Let me just make an example very quickly from the engine manufacturer perspective. Something not everybody appreciates is that the gas turbines, no matter what it is that you combust, is it kerosene, is it sustainable aviation fuel, perhaps one day even hydrogen, they operate at temperatures above the melting point of the materials they're made of, which is amazing, right? So what excites me really is working on new alloys, so new materials which allow to increase the temperatures. If you increase the temperature, you're more efficient. You burn less, and you emit less. So new alloys, nickel alloys, super alloys, and also new manufacturing technologies which allow you to design your component so that air can flow through it and cool down the structure and, prevent basically the gas turbine component from melting.
And I think after that you're quite convinced that scientists and engineers are part of the solution, not part of the problem.
No, please, no.
Come first. You want to end, okay. But trying to take it back to a question, what is the most promising technology out there? What shall we look at? And maybe taking it back to the question of the fourth revolution of aerospace, so decarbonization, then really we try to see it from the overall aircraft system perspective. So every component brings something and needs to bring something because the question is so big. So first and foremost, of course, we have propulsion, we have the energy question. So that brings us in all these questions of what will be the next level of engines, the next propulsion system, and the next propulsive element as well. Then you have the wings, a second component bringing kind of most aerodynamics. How can we go further? What else? Everything is about the mass, the weight of the aircraft flying at the end. So it's all about new materials, better materials, lightweight design, and the way we can manufacture it. And here you come all the way, of course, into every single system and how you optimize the whole. And you need the digital, because we have much more different ways of calculating, going far further in the models that we are creating, and in the improvement and the optimization of the models, is actually allowing us very different configurations in the future. And this is what we see. So basically, yes, it's all of them.
So maybe as a conclusion, to try to get an answer to your question, I encourage you to visit deeply the Paris Air Lab. You have mostly all the levers which are displayed here. Operations, sustainable aviation fuels, a new configuration, etc. So I encourage you to deeply visit, and if you have some answer, tell me. It will be of interest.
Fantastic. Thank you all. What a great ending, Bruno. Thank you. And I know I'm conscious of our time here. I think we could all spend the rest of the day here if it was a little cooler. But thank you all for your participation, your engagement. Thank the CTOs. Thank you. I would like to just add 2 quick comments just to give you an idea of what is next. So as you can tell here, we have our CTOs, this forum. We are partnered with Royal Aeronautical Society, AIAA, Society of Women Engineers, and we, as a working group specifically on moving forward STEM, starting in Europe. We're a team that started in March. We've already been working with representatives from every one of these companies and organizations, and already have some plans on what we're going to do. We're going to launch those plans this fall. And we're going to work to go out into the community to talk to teachers, talk to students, talk to parents, gather feedback on how we can best engage from an in-person and a virtual perspective for STEM as a forum, as a company. And this will help combine it with the organizations that we have here and their existing work, but really to complement that and continue on with how we can bring STEM to future engineers. Todd, you want to add?
Yeah, thanks. I just want to thank all my teammates here. Hopefully you can see we're all very passionate about this subject. And the reason is aerospace has truly changed the world in a very positive way. If you think about the innovation both in space and in aviation and the improvements in efficiency, aviation has contributed trillions of dollars to the world's economy. Aviation employs, aerospace employs hundreds of millions of people around the globe. And having said that, the vast majority of people in the world have never stepped on an airplane. So there's a huge opportunity to further fulfill that human need to connect. And we clearly need to do that in a sustainable way. And we can do that, but the key to doing that is we have to have that constant infusion of talent. And so we're very passionate about the importance of STEM and STEM education and creating the opportunity for you to make the mark on the world by being part of aerospace. So I encourage you to join us in what has already been history making and has great opportunity in the future. So thank you to all of the team here, and thank you to you.
Thank you all. Thanks very much again for being here with us. We had the CTOs from Airbus, from Boeing, from Rolls-Royce, Safran. Everyone was here. It was fantastic. Thanks very much again. We have 2 appointments this afternoon at 3 p.m. We're going to have the rocketry challenge here. So we'll talk about a challenge to send rockets in the sky. And at 4:30 this afternoon, we're going to have startups. 7 startups will be here and will talk to us about electric propulsion, hydrogen-powered aircrafts, sustainable aviation fuels, you name it. All the innovation is here at the Paris Air Lab. So thanks again to you all, and we'll be back at 3 p.m. for the Rocketry Challenge. Have a nice lunch.